Hi, how are you? In this video, this is the last part of calculus and we are going to study differentiation. Before this video, we have studied in first, second, third part all these terms in detail: infinitesimal, limit, continuity, function, integration. And in last means third part of calculus, in that lecture, this was the end of the lecture. What was the end? Integration and differentiation are reverse process. You can say opposite process. I have explained. That is the fundamental theorem of calculus. But remember these two statements. Integration is total, not large, and differentiation is rate of change and not small, because it is generally misconception. Generally some students take, if it is very small, then you can see it is derivative or differentiation. No. If it is very large, integration. No. It is summation, it is integration, but it is total, it is not large. How? I have taken one simple example. If speed of car is 120 km/h, then total distance covered during 1 minute is 2 km. Simple mathematics. And if speed is constant, then there is no problem. Now, what is derivative? What is integration? You can observe. Speed is nothing but the V is nothing but the total distance upon total time. Whatever time I have taken, you don't know, I don't know. But this is total time. This is total time and this is total distance. At particular time, if time duration is very small, at that time suppose I want speed, that is called instantaneous speed. This is average. That instantaneous speed is nothing but the derivative. Then you can obtain by this method. And we have seen in second video how that limiting process is. Limit delta t tends to 0, delta x divided by delta t. This is the limiting process of delta t. Then we get speed at that instant. At which instant? Where we want speed. And that speed is 120 km/h. You can observe this number. This is derivative. Means it is something changing with respect to something. Means distance is changing with respect to time. And total distance covered during 1 minute is 2 km. You can see 2 km is integration. That is total. You can observe these two numbers now. Integration is 2 and derivative is 120. Means there is no any meaning of large or small. There is meaning of total and rate of change. These are the basics. In this video, we will see how we can differentiate between two quantities. Means what? Suppose something is changing with respect to something, that ratio is nothing but the derivative or nothing but the differentiation. I will take two simple example and then we will enter actual derivation of any function. You can say sine x, you can say x square, you can say x, simple x, okay. And then we will see how it is change of something with respect to change in something, that is derivative. We will see. Here I have drawn one mountain, one cliff of mountain, and at top we have to go. There are two ways, two roads. One is this white road, ghat section, just like ghat section, okay. By turning you can go on the top, general. And another road that is difficult, that is the straight slope, pink color slope. Okay. This white color road having smaller slope, but this having larger slope. How you can observe? Suppose you are going from this point to this point, means from A to B, means actually you are moving along horizontal direction by dx meter, and also you are moving in upward direction, means this BC. Means there are two motion, horizontal motion, vertical motion. In this case also, I have taken same horizontal displacement, but from P to Q, we can cover only small displacement, that is dy by 2. You can observe this QR is small compared to BC, but horizontal displacement is same. Means this path having less slope, this path is having more slope. From your geometry point of view, you can say this BC upon AC means this change in y upon change in x is nothing but the tangent of angle, means you can say it is tan theta, means slope is nothing but the tan theta. I have given name slope 1 for this pink color, and for this white color I have drawn tangent to that road, because road is curve at particular point. I have drawn curve, tangent. All these tangents are parallel because our road is perfect road. Okay, and these tangents you can observe from top, you can draw one line. Means suppose there is another road, imagine it. If this road is constructed, then you can say this slope and this slope will be same. If it is theta 2, this must be theta 2. Then you can observe that for same horizontal displacement, there are different vertical displacement for these two separate roads. This is nothing but the derivative of y with respect to x, means change of vertical displacement with respect to change in horizontal displacement. In this case, I have taken both quantity as displacements. In this case, I have taken lift. Lift is not going in horizontal direction, it is going in upward direction, means along y axis, up and down. Okay, means along y axis only. Means for this case, you can write slope as slope is equal to dy upon dx, but there is no dx. It is not going in horizontal direction. That's why you can write here 0. But something upon 0, we can't determine. You can say it is infinity. Now you may object, why can't we divide any quantity by 0? I will give one example. Suppose there is one cake and I have to divide into 10 parts. I can divide equally. That piece will be small. It is 1/10 of the total volume. Suppose I have to divide into 100 parts. I can divide. I can divide into 5 parts. I can divide. I can divide into 2 parts. Then that parts will be more, means having more volume. Equal 2 parts. I can divide. I can divide into 1 part. Already it is 1 part. Means not necessary to cut. But suppose I want to divide into 0 parts. Means what to do now? 0 parts means what? If you are cutting, then there will be no 0. It will be more than 1. And if it is not cutting, then it will be 1. Means you can't cut. Means there is no valid process to make into 0 quantities. That's why we can't divide any quantity by 0. It will be infinity, indeterminate. Okay. Now, as we have seen, it is very simple. What is derivative? But our problem in mathematics, what is the problem? Derivative of x with respect to x is 1. Derivative of x square with respect to x is 2x. Derivative of sine x with respect to x is cos x. We will see and we will get clear actually what is happening? Means how can we believe that yes, derivative of sine x is cos x? We can believe from our 10th or 9th standard mathematics. Okay, we will see. There are number of formulae for derivative and integration, and you can take from your mathematics book. Now, one of the basic formula of derivative of x raised to n with respect to x I have written. If y is equal to x raised to n, means if y is function of x by this way, then you can write derivative of y with respect to x as n x raised to n minus 1. This is formula. If you are accepting that formula, no problem, you can solve any problem. But question is why it happens, means actually why it is shifting to this side, this n, and why there is subtraction of 1 from that n. Means how can we believe yes this is the correct way? Means this y is changing with respect to x by this way. We will see. I have taken two simple examples. If y is equal to x, means as x change, y change, x doubles, y doubles, x triples, y triples. Means our graph is very simple, straight line passing through origin and making 45 degree with x axis, simple graph. Now you can observe if x is 0, y is 0 because graph is AB. If x is 1, y is also 1. X is 2, y is also 2. X is 3, y is 3. Now I want slope of this graph. What is slope? dy by dx, difference in y upon difference in x. I have taken these 2 points. You can see it is P and Q. Difference in y means y2 minus y1 upon x2 minus x1. But y is equal to x means y1 is equal to x1, y2 is equal to x2. Then you can put y2 as x2, y1 as x1 and keep this x2 minus x1 as it is. Means x2 minus x1 upon x2 minus x1 is equal to 1 if x2 and x1 are not same. This is the condition, x2 is not equal to x1. As it is straight line graph, no problem, whatever the value of x2 and x1, they must be changed, but they must not be the same. For this graph, that is a different thing. For this graph, it must be different, but the difference may be large or small, no problem. Then you can get cancelled and you will get answer 1. Then you can say derivative of y with respect to x is equal to 1 if y is equal to x. Means if y is equal to x, then dy by dx is 1. By that formula, you can put here as 1. Means x raised to n means x raised to 1. By shifting this n here, means by formula you can write dy by dx as, shift this 1 here as like n you have shifted, x as it is, and this n minus 1 you have to write 1 minus 1. Means answer is x raised to 0 into 1. X raised to 0 is 1. Means final answer is 1. Why x raised to 0? Because actually it is x upon x, means x raised to 1 upon x raised to 1. By shifting, you can write x raised to 1 into x raised to minus 1. That is simple power rule. Means by formula you can directly get answer. But what is actual physical meaning, physical significance? This is the physical significance. Similarly, now you will see y is equal to x square. By this formula, you can write 2 here. X raised to 2 minus 1 means 1, x raised to 1 means x. This is the direct answer. What is the physical meaning of this 2x? Means y is changing with respect to x by this rate. How? We will see. As y is equal to x square, you can put the values of x and you will get value of y. Suppose x is 0, then y is 0, means point is here. Now this is your starting point A. If x is equal to 1, then y is equal to 1 square means 1. I will get 1 here. This is not perfect scale, but you can draw by using your scale in your notebook. If x is equal to 2, then y is equal to exact 4, 2 square. X is equal to 3, it will be y is equal to 9. By joining this continuous graph, we will get this curve, and this curve, in this case slope is same. In this case slope is different for each and every point. You can see my hand, my palm. Suppose at this point I want slope, then this will be tangent. At this point I want slope, then you have to draw tangent. At this point draw like this tangent. Means slope is increasing in this case. As slope is increasing means rate of change of y with respect to x is increasing. In this case it is not increasing, it remains 1. Means whatever the value of x is changing, there is no change in the rate of change. That's why it remains constant 1. But in this case what is happening? See, slope is dy by dx means y2 minus y1 upon x2 minus x1, but y is x square means y2 is x2 square, y1 is x1 square. Put the values. Then we know a square minus b square is equal to a plus b, a minus b. Put here. Then x2 minus x1, x2 minus x1 can get cancelled if x2 is not equal to x1, means that is the limiting. Now if this is the condition, you can get cancelled. Then you will get only x2 plus x1. dy by dx is x2 plus x1. But as x2 is very close to x1, tends to, dx is tending to 0, means both values are very infinitesimal close, then you can put both are almost same, that is x. Then x plus x is 2x. Means if x is 1, then you can say rate of change of y with respect to x is 2. And if x is 2, then the rate of change of y with respect to x is 4. Means as x changes by 2, then y will change by 4 with respect to x. That is the rate. Means at any point you can draw tangent. At this point, suppose I have taken 1.5 here. Means at 1.5, value of x is 1.5. Value of x is 1.5. Then I can say this y will change. Y will change as this rate. Means 3. 3 means what? If dx is 1, then dy will be 3. If it is 1.5. If it is suppose 4, x is 4, then what will happen? This will become 4. If suppose it is 5, then it will become 10. Means its rate is increasing. Dy will increase fast as dx increases. This is the physical significance. Okay. Means every time you have to remember this y is changing double of the value of x where you want the tangent, where you want slope. At which point you want slope? This point you want slope, this point you want slope. At every point of graph, the slope is changing, means rate of increasing is changing. That is the physical significance. And one more example I will take of sine x. Means we will prove how sine x is exactly physically, how it is, we can compare. If sine x is y, then change of y with respect to x is cos x. We will see. This is our last example. I have taken function sine, means y is equal to sine x, is function of x, that function is sine. Now dy by dx means derivative of y with respect to x can be written also f dash of x. This is also by not Newton, by Leibniz. Okay, this is also symbol of Leibniz. Is equal to, again the same, limit dx tends to 0, y2 minus y1 upon x2 minus x1, rate of change of y upon rate of change of x, means actually change of y upon change of x, means rate of change of y. Okay. Now dy by dx is equal to, you can put y as equal to sin x, means y2 is equal to sin x2 here, y1 sin x1, means x2 minus x1 as it is. But dx tends to 0 means what? X2 minus x1, that difference tends to 0. Means what? X2 minus x1 is very means infinitesimal small. We can't imagine this very small number, that is h. Now you can put x2 minus x1 as h. Now dy by dx is equal to limit dx tends to 0 means x2 minus x1 tends to 0, and x2 you can put here as x2 minus x1 is h, means x2 is equal to x1 plus h. You can shift this one. Now x2 can be replaced as x1 plus h, minus sin x1 as it is, x2 minus x1 means x1 plus h, this x1 plus h minus x1, or directly you can put h as it is, no problem. Now you know in 10th standard that sin a plus b, it is sin a cos b plus cos a sin b, that is our formula. Now you can solve by that formula, this form. It will be sin x1 cos h plus cos x1 sin h minus sin x1 as it is, and this x1 minus x1 gets cancelled, we get h, simple. Now this will look like this one, because I have taken sin x1 common, this sin x1 common, then here cos h will remain, and here it will be 1 minus 1, cos h minus 1, and this h as it is for this first term. And for second term, limit h tends to 0, what is remaining? Cos x1 sin h, cos x1 sin h, and h as it is. Now when you apply this limiting condition, limiting process condition, then you can say cos h tends to 1, then you can write here 1, because h is very small, means final limit will be cos 0, but you can't directly put 0, but it tends to 0, that is why cos h becomes 1, then 1 minus 1, and this h as it is. Here cos x1 as it is, because h you have to put here, but it is not 0, it is very small. Then you can say sin h upon h is equal to 1. Again doubt why it is 1, because suppose you know what is sin theta? Sin theta is opposite upon hypotenuse, means BC upon AB. Now you can decrease the value of theta, then BC will be very small. As BC becomes very small, infinitely small, then you can say this will look like a straight line, means AB and AC is about to coincide. Then BC becomes infinitesimal small. Then BC can be treated as straight line or can be treated as curve. Then this theta can be written as BC upon AC. And we know sin theta is also BC upon AC. Means for very small angle, we can write sin theta upon theta is equal to 1. That's why I have taken 1. But this value is 0. Forget this one, we will get dy by dx as cos x1. But again we know x1 tends to x2. They are very close to each other, then you can write it is cos x, because value is almost same. This is the your mathematics say. Now we will say physical meaning. What this cos x means actually. I have drawn graph for this curve, for this equation, means y is equal to sine x. X is nothing but the angle. I have taken angle in radian, 0, pi by 2, pi. Okay, I have drawn only for up to pi. This is pi by 2, this is pi by 4, this is pi by 6. Okay, by putting the values we will get graph like this one. Means for pi by 2 sine 90 is 1, then I will get 1. This point will be 1. Pi by 6 sine 30 half is half, I got half. Okay, similarly I will get different values. You can use calculator and your scale and you can develop graph. I have shown two tangents. One tangent at top. Okay, top means at angle pi by 2, means value of x is pi by 2, and at pi by 6 I have drawn tangent to the graph. Now what is dy by dx is nothing but the slope of tangent. Now, what is slope of tangent? Here I will say x2 minus x1 is here. As usual, here y2 minus y1, but y is sine x, means sine x2 minus sine x1. And suppose you have taken actual values of what is the x here, what is the x here, and take the difference, that is x2 minus x1 actual, and take actual values of this y2 and y1. You can put, actually I have calculated all this, but it is not necessary to all these values should be shown here, but you can develop. Okay, after putting we can calculate, and the value we get is 0.86, means slope at this point I got 0.86 value dy by dx, which value at x is equal to pi by 6, means at pi by 6 if I am getting slope, means change, rate of change with respect to x, I am getting 0.86, but that rate of change with respect to x is nothing but cos x, means at pi by 6, suppose you have see what is cos of that pi by 6, it is also 0.86. That's why you can say the rate of change of sine x with respect to x, the value is exactly equal to cos of that x where you have developed slope. This is physical significance. This is actual meaning of derivative. At this point, what is the slope? There is no slope, means what? There is no change in y, means dy will be 0, means for this dy by dx is 0. At which angle I have drawn slope, tangent? At pi by 2, means if y dy by dx is 0, means cos of this value must be 0 then, and we know that cos pi by 2 is 0. That's why, means actually you got direct formulae, means you have got ready-made answers, no any problem, no any exercise for you, it is ready-made. Means don't fear about formulae, actually it is your decreasing your effort formulae, but physical significance, physical meaning is like this one. I think you got what is integration, and there are number of formulae, means actually you are bypassing the all systems if you are getting formula ready-made. Okay, but at least that memorizing formula is not interesting thing, it is somewhat tedious, somewhat boring. Okay, but simple way I will say, you can put all formula on your wall or anywhere, and you have to see, only see the formula. In photo memory, generally it is not actually photo memory inside it, but science says, biomedical says photo memory. In photo memory you can visualize those formulae. Okay, after this there will be only physics lectures. Yes, there may be mathematics lectures, means about logarithm or what is trigonometry, okay, there may be. But after this, lectures will be on gravitation field, electric field, magnetic field, and after covering this, there will be two separate sections, maybe 2 or 3 parts for each section. There will be relativity, Einstein's relativity, and quantum mechanics, okay, in simple language, because the relativity is somewhat different, because there is one more dimension is added, that is time, Einstein said, okay, but we can enjoy that dimension also, okay. Till then, enjoy. I am also enjoying, you have to enjoy. Bye, thank you, take care.